an array, and you can pick up any index, and you just need to say on which day it will get warmer. So when do you say the current is, for example, this is day 1, day 2, day n, so which is represented as 0, 1, 2, 3, or let me represent this way. So let's say this is day 1, this is day 2, and day 3, day 4, and day 5. So we need to see when day 1 get warmer. So when do you say day 1 can be hotter compared to the current day? It means the current day temperature is less than or equal to the less than the next day temperature. For example, in this case, for 30th, in day 1 it is temperature is 30, so that day 2 it is temperature is 60, so that definitely within a one day it will be more warmer. When it comes to day 2 temperature is 60, but day 3 temperature is 70, so that within one day it will be more warmer. Now when you compare to day 3, and if you traverse the complete array, so there is no, you cannot find a day which is warmer than the current day 3, so that other than this on so there is no day which is greater than temperature 90, so that you can simply return -1. In this case, day 4 you have 20, and day 5 you are getting 40 temperature, so that obviously within a one day the temperature will be more high, so that you can give 1 here. Similarly, in this case, you can simply return -1 because there is no other day. For example, if you have one more input, something like this, let's say you have input something like 100 in day 6. So definitely, if you closely see, on day 3 you have 90, then after 3 days you will have higher temperature, so that obviously here you return 3. Then in this case 40 becomes 1, because within one day the temperature will be higher, so here it is -1. You understand the problem statement, right? Correct. How do you
Yes.
want to solve it? Okay, so how do you want to solve it?
Maybe similarly like how we did yesterday, maintain the stack and then keep pushing it. So for this next item, we will check for the previous one.
So how do you want to traverse?
Uh,
Is it from, how do you want to traverse to solve this problem? And more importantly, we need to return in the form of days, right? It's not in the form of
okay,
number.
difference we have to.
Yeah, so
Uh,
difference we have to take it. And how do you start the algorithm, and what do you keep in the stack?
so instead, I was thinking the temperatures only.
Okay, in the stack you keep temperatures. Okay, okay. Then how do you start? You're starting from front or back?
Friend, I mean 30 from 30.
Okay, so for example, you keep 30. Then
Then for the next item, 60 we
mm,
will check if 60 is greater than 30, then we will pop and say 1.
where do you keep
How
one?
many elements popped, that many.
Okay, so I popped. So where do you keep that information? That one, where do you keep?
In an array that we take extra output. I mean, we
But
need to return an array, right?
yeah, so we need to return an array.
At what index you are saying? The removed
Yeah,
index.
yeah. So let's say you have indexes. Total you have 6, right? So 0, 1, 2, 3, 4, 5. Don't worry. So why I am discussing all these points is you can understand the complexity, so that we can come up with proper algorithm. So initial thought is we will go for 30. Okay, 30 will be in the stack. Then we take 60, and we understand that 60 is greater than 30, so that we will remove it, so that count is 1. So where should I keep this count?
At index 0.
Okay, so let's keep 1 here. Now you have 10, 90, and now you understand that there is only one element, so again you get 1, so it is at index 1. Okay, now you get 20, right? 20, which is not greater, so that you keep it same, is it? And 40.
If we do that,
Then when
then we
it comes
miss
to 40,
90.
right? So when
Right?
it comes to 40, 1 will present here, but you may get disturbance in the result, right?
Yeah.
Yeah.
Do you have the proper track? So there is no proper track here. Then what could be the best way?
I think if we come from back, that would be good.
Yeah, if you come from back, that will be good, because you always have a valid result, right? So if you come from back,
Yes.
so you always have a valid result for the first element. Then we'll see how it works. And one more thing, if you keep temperatures in the if you keep temperatures in the stack, right? Let's say you have duplicate temperatures, then you don't know which temperature is belonging to which index, so that will also leads to the confusion. So that what we do, we will keep indexes in the stack. Okay, so stack contains indexes. Okay, so then we will start from back. So let's do that. So first I will start from here. So I'll start from here. So initially stack is empty, right? So initially stack is empty. So definitely the last, so initially stack is empty, so that this indexes are 0, 1, 2, 3, 4, 5. So let me keep index 5 into the stack. Okay. Now obviously for the last element, right, always the value will be -1, because there is no element to compare, so that you can just ignore that. Then when you move further, so when you come to index 40, index 4, you have 40, right? Now if you closely see, at index 4 you have value 40, and yeah, and at index 4 you have value 40, and which is less than the top value. So the top value is, in the top value you have index 5, so index 5 is representing 100, so 40 less than 100, so that I can blindly take this value. So whatever value I have, 5 minus the current index, which is 4, so whatever is the difference, you can store that difference here. Perfect, so I store here. Then let's move further. So definitely 4 will be present at here, so it means at index 4 this is the value you keep, so you will keep it. Now well, let's move further. Now you have 20, right? So now you have 20, so that 20 means now top is pointing to index 4, which is having value 40, and current index is 3, which is having value 20. So 20 less than 40, so definitely I can take this index minus the current index, so which is going to be 4 minus 3, which is 1, which will be replaced in the current index, so that at index 3 again you have 1, so that again you keep 3 here. Now this is more important. Now again when you come here, so when you come here, this is more important. So at index 2 you have value 90. So what you can do, you need to find out the next greater element, right? So the 90, so at index 3, so on top you have what, 3, it means 20, 90 greater than 20, so I delete this top. Okay, so this is not needed. Now again you will compare 90 to the next element, so fourth index you have 40, so 90 greater than 40, again you delete this. Now when you compare the next element, right, so it means at index 5 you have element was 100, so 90 is less than 100, so you found the valid one. So that what you can do, you can take that index, so which is 5 minus the
Mine.
current index value, which is what, 20, so 5 minus 2, so which is going to be 3. So 3 will be replaced in the current iteration index. Current iteration index is 2, so at index 2, so you will have 3. Then again you will keep current value, so which is going to be 2. Now let's move further. So you have at index 1, so at index 1 you have value 60, which is less than the top index value 90, so that the difference will be 1. Then you move further, so you are at index 0. At
And
index
one
0,
question here.
yeah,
As in we find the next greater, we break it, right?
yeah, so
Otherwise, we
we
have
don't delete,
for
right?
the
We don't
yeah.
delete. Yeah. So the catch is whenever you find if the current iteration is smaller than previous element, If the current iteration is smaller than previous element, you can blindly insert it. You already know
Yeah.
the answer and you can insert the current element. Why? Why, buddy? Because this current element can be larger than previous element, correct?
Correct. Correct.
That's why you keep the current into the stack. But if the current is greater than previous, right, then you don't need previous, right, in the stack, so you keep on delete the previouses. Why? Because whatever previous you have, you can keep on delete it, because this current is going to be greater than definitely if this is greater than whatever deleted element which is greater than previous elements, if it is greater, then this will always be greater, right? Current is
Correct.
always be greater, so that you don't need to maintain these elements in the stack, so you keep on delete those elements in the stack. So that's how you can make sure that you don't revisit the same element more than once, more than
Okay.
twice. So in worst case you can revisit the same element twice. So that's why the time complexity will always be linear. Is that clear?
Yes.
So what is the time complexity you could see here? What is the time complexity you could see here?
It is linear, but
So
as
when
Yeah, Michael.
checking the stack again. So big of n for traversing the array,
Hmm.
and for each item we will keep checking the stack.
Hmm.
So that could be less than n length only.
Yeah. So actually,
Maybe the previous how many items were traversed.
yeah, perfect. So the thing is, we traverse the complete array. Okay, so we are traversing the complete array for sure, and for each traverser, for each element traverser, we are looking on the stack, right? When you are
correct.
looking on the stack, even in worst case, you can visit the same element twice,
Right.
not more
Correct.
than that. So that definitely which is going to be linear. And when it comes to space complexity, you are maintaining the stack, right? So obviously one is result array, another is stack. Let's say all are in increasing order, so all are in decreasing order. Let's say something like 4 3 2 1. Then you will find always difference as 1. All these elements will present in the stack, so that the stack size will be linear, and your result size also will be linear, so that which is going to be big of n plus n. Clear, right?
Yes.
And you can you can write the code for this. Hope you can do that now.
Yes.
So let's discuss the other problem. Yeah. So if you are able to solve this problem, I think you can easily answer this problem. So let's solve this problem. Okay. So this is a ocean view. So if you are able to solve the previous problem, then this is becoming dead easy. So let's say you have four, 2, 3, 1. Okay. So problem number is 1762. So let's say you have 4, 3, 2, 1. So these are the values which were given. So let's say you have ocean here. So you have ocean here. So you just need to see the view. So here you have one.
See the note.
Sorry. Yeah. So let's say you have one. So we need to find out ocean view. So you have one, and you are also having one more value as two. Then you are also having one more value as three. Is it 4231? Yeah, it is 4231. Okay, so let me erase this. So we need to see the, let's say you are giving the buildings, the building heights are provided. So we need to see the ocean view from the right. So this right building size is 1. Then after that you have size as 3. Then after you have size as 2. Then after you have size as 4. Now if you call, we need to return the ocean view. So can see the ocean or not. If you can able to see, we need to return that index. So if you closely see, these are the indexes, right? So these are the indexes 4, 3, 4, 2, 3, 1. So which is at, if you consider 0, 1, 2, 3. So this is at 0th index, first index, second index, and third index. So now can 0th index, whatever building you see on 0th index can definitely see the ocean, right? Correct? Because it is taller, correct? So it can see the
Yes.
ocean. And is it, can index 1 see the ocean? It cannot, because it has the,
3 years
yeah,
obstacle.
3 as a obstacle, right? So then can index 2 can see the ocean? So definitely it can see, because there is no obstacle. And this one also can see the ocean. So that we just need to return those indexes. So 0, 2, 3. So this is the expected answer. So can you tell me how do you solve it? So I don't help you on it, but can you tell me how do you solve it?
We just need to check from the end if starting the last element can able to see. Before that element, just check whether it is greater than previous element or not. If we are traversing from reverse,
Mm.
that way we can do that. As 3 is greater than 1, it can see the
Then,
ocean
yeah, how
view.
do you maintain the data in the stack? So now stack contents, definitely that's the right answer, but can you tell me how do you maintain the data in the stack? At the end, we need to return indexes in ascending direction, 0, 2, 3, right?
Correct. Okay. We can maintain the max from.
Okay, forget about the result. First, tell me how do you proceed on the algorithm?
Just check as we check through the array, we keep the indexes in the stack, and
Okay.
then later we can just
Okay, so this is our indexes, right? 0, 2, 1, 0. Okay. Okay, 0, 1, 2, 3. So this is my stack. Okay, so let me go with it. This is my stack. So obviously the last, so I must and should traverse from backward, right?
last.
So because this will have perfect answer. The last one doesn't matter what is the height it could be, it can see it. So that
Correct.
index 3 can see it, right? So that I will keep the index 3. Now what else can I'll compare? Can index 2 see the ocean? How can I know that?
By checking whether it's greater than
Top, right? So
top. Yes.
so it means if it is greater than index 3, so yeah, 3 is greater than 1, so that index 2 also can see, so that 2 I can keep.
Yes.
Now can index 1 see it?
No.
Because if it should be greater than this one, right? So because index 1 having value 2, and in the top you have index 2 which is having value 3, and 2 is less than 3, so that index 2 can't see it. So definitely you don't need to insert index 1 can't see it, that you don't need to insert index 1. Then let's move on to index 0. Can index 0 see it?
Yes.
How do you know that?
We pop the last element from the stack, and then
We don't
the
pop it, we will just only check it, because
keep
we need those
check it.
elements to the answer, right? So
Yes.
the current index is 0. In the stack you have index 2. Okay, so at index 2 what is the value you have? 3. And the current index is what? 0. So 4 is greater than 3, so definitely we can see, so that you can keep the 0. So now whatever elements you have in the stack which will have the result, so that you just need to pop from the stack. You can take one result array of size 3, pop from the stack. So first element is 0, second element is 2, third element is 3. So these are the indexes, you will just return it. Correct?
Yes.
So what is the time complexity here?
It's linear.
More importantly, how do you know that 0 can see? By just comparing the previous element. So I'm at 0th index, right? And I'm blindly
Hmm.
saying that 0th index can view the ocean by just comparing the previous element, which is at index 2. How do you know that? How do you confirm that?
Why? Because we are not inserting the element which is lesser than that, right?
Mm.
That's why
Maithili,
we
is
are
that
so
clear?
sure.
Yeah, I got it. Maithili, is that clear?
Yes.
Yeah, so only the point is, yeah, if it is greater than previous means definitely whatever element you have on the top, right, which is always be larger than previous elements. If the current element is greater than previous element, then obviously it is greater than all other previous elements. So that's the trick you can follow on monotonic stack. Akash, is this clear?
Yeah, it's clear.
So let's move further. You can solve these two problems. So here also the time complexity is still. What is the time complexity here?
It's linear.
Yeah, linear. We are just traversing the array. And what is the space complexity? So this is for
It's
result.
also linear.
So
Yes, result and
so for
it's linear.
resulter also it is going to be linear. Let's say all are in decreasing order, so everything can view the ocean, and in that case stack also will take the same space. So this will also take linear space. Okay, so let's move on. Okay, I think this also you can answer, but I will write the code for it. But meantime, we will discuss about it. Yeah, this is very interesting problem. It's a design problem. We need to design the code. So what he is trying to say is, you keep on getting prices. So okay, to this price, you keep on getting the prices. So we just need to return. Okay, just a minute. Yeah, yeah, understood. So yeah, so you will be given a, so it's a design problem. Let's talk about it. Okay, let's talk about it. This is 901. But this is not hard problem. I want you to tell me the algorithm. If you are comfortable, you can only write the code. Otherwise, I can write the code. So 901. So what he is trying to give is, it's a stock spanner. Sorry, it's a stock spanner. So you will be getting a, there is a method called next. If you see here, you have a method called next. Here you will keep on getting the prices. So initially the first price you get has, let's say 20. So this is the first element you have in the stock. uh, so obviously there is no element. So the idea is, when you get a stock price, uh, when you can find largest stock comparatively the current stock price, you need to return that count, that spam count. So in this case, let's say you have 20. Right now you don't have anything, so definitely including current element you return, so definitely answer is 1. Let's say I will have 40. I will have 40. So if you closely see, now the current element is 40, and whatever previous days you could see, right, there is no greater element comparatively the current element, so that you will only consider current element, which is 1. Again, I will take element, let me take element 30. So if I take element 30, if you closely see, in the previous day you have higher price, so that you can consider the spam count as current element, and previous next greater stock price, so obviously which is going to be 2 30 plus, current is 30 and previous is 40, so that you can return 2. For example, if I give 35. So let's say 35. So if it is 35, let's see when is the last, when you backtrack, so when is the highest price you can find. So I can find here, so that definitely 1 2 3, so we just need to return 3 here. So let's say I will have something like uh, 41. If I have 41, then what is the value I could return here? If the current price is 41, and we need to find out what could be the previous day highest price, that spam count we should return. When it is 41, you see here, there is no, you don't find any stock which is greater than 41, so obviously it will again 1. Okay, it will again 1. Is this clear, Kalyan, Akash?
Yes.
If I walk through the given example, So let me walk through, give an example. So this is the example. If you see here, initially 100, so that it is 1, again 80. Mm, is it reverse what I said? Okay, 80 again 1, 60 again 1, 70 which is 2. Okay. I just explained in reverse order, so let me explain in proper way. What is the problem statement says? Okay. Design algorithm that collects daily price codes for some stock, return the spam of that stock price for the current day. The spam of the stock price in one day is maximum number of consecutive days. Okay, so maximum for which the stock was less than or equal to the price of that day. Okay, so 7213. If the current stock price is 2, then okay. Yeah, I just explained in reverse direction, so let me explain properly. So let's understand, let's take the given input. So initially you will have 100, okay, so 100. So what he's trying to say is, let's say you have stock prices as 7212. This is the stock prices you have for each day. This is day 1, this is day 2, this is day 3, and this is day 4. You have stock prices recorded for each day, and the current stock price is 2. And we need to find out what is the long span for the current price. So let's say you have 7 here, and then you have 2 here, then you have 1 here, and again you have 2 here, and the current stock price again 2. So this is the current stock price, so which is again 2. So we need to see long span. So span can be calculated as current stock price, whatever current stock price you have, so which is greater than or equal to the previous day's price. So in this case, if you closely see this section, right, this whole section can be represented as one span. So this whole section can be represented as one span. So because current stock price is greater than or equal to previous days, so the total count you can return as 4. So we just
Can you
need to
remove Zoom meeting that is coming in between? Thank you.
Okay. So this is what it is, right? So you have 7212, and the current stock price is 2. So this is already previous days stock prices which are logged, and this is current day stock price. So we need to return the longest span. So longest span is equivalent long. How do you find out longest span? So this current day, right? So current stock price is greater than or equal to previous day's stock price. These are the previous day's stock price, and this is the current stock price. If you see, this is going to be the longest span, because this current stock price greater than or equal to previous days, so that for this the output is going to be the 4. Okay, so the output is going to be the 4. Let's say I will have one more element called 9. So if I have one more element called 9, so the current stock price is 9, right? So that it means something like this. It will go something like this. So current stock price is 9. So this is my current element, and there is no longest span, right? So it means if you closely see, current day price is 9. So if you see, all the previous days prices are less than the current day price. So for 9, it definitely it is 1. Let's say I have element 12. Now again, if you closely see, this is my 12, element 12. Now if you closely see, with this is my current price. So previous days, what could be the, so current price which is always greater than or equal to all previous days, so that you can consider all the previous days, and this is going to be my longest increasing span. So increasing span with respect to current day, so the total will be 1 2 3 4 5 6 7. So you just need to return 7. Is that clear, buddy? Is the problem statement clear? Kalyan, Akash. Not clear?
For 12, it is 1, right?
Why it is 1? What I'm saying, longest span, right? We need to return longest increasing span. Let's say initially stock price is 7. Okay? So spam can be calculated based on longest increasing stock price
Okay.
with respect to current day. Okay, so with respect to current day. So let's say current day stock price is 7. There is no element to compare, right? So that in this case the output is 1. So definitely, because there is no element to compare, in this case the output is 1. So let's say I have next I have element 2. Next stock price is 2. So what could be the longest increasing span with respect to current day? There is no increase, right? Yes or no, buddy? Yes or no?
Yes.
So with respect to current day, there is no increase. So that obviously which is going to be 1. So that's the expected output. Let's say next stock price is again 1. Now again there is no longest increasing span, right? So that again here the output is 1. Now next stock price is 2. Let's say next stock price is 2. So this is 2. Let's say next stock price is 2. So in this case, if you closely see, the longest span can be calculated as per the problem statement, the longest span can be calculated as current stock price is greater than or equal to previous day stock price. So if you closely see, to the past 3 days, if you consider including current day, the price is greater than or equal to, right? Yes or no?
Yes.
So that
Yes.
in this case, the longest span is going to be 3.
Th- Three.
Now
Correct.
let's say I will have now the current stock price is 9. So with respect to current price, there is no longest span, right? So which is the highest, correct?
Correct.
So obviously this is going to have 1, so because the current stock price is higher. Now let's say I have 12 again. So let's say I have 12. Now, if you closely see, the current stock price is 12. So, which is maintaining the longest span, right? All the previous days stock prices are less than or equal to current stock price. So, that obviously you will calculate all the previous days. So, which is going to be 6. So, we need to have
Shri, for 9, why didn't we compare with 2?
That's what.
yeah. So what problem statement says longest increasing stock price with respect to current day. So how do you know that increasing stock price? Yeah, sorry, it is 9, right? So for 9 definitely we need to consider previous days, right?
It would be.
It would be,
From 2, from 1 we have to
yeah,
consider it.
so it should be 5.
Yeah.
It
Right.
should be 4.
Yeah.
So for 12 it is 6. Then for example you have element again 5 here. Then what is the answer?
It would be on
It should be 1,
1.
right? Yeah.
one, right? Yeah, one.
Yeah.
Respect
So
to the
with
previous.
respect to current day, so previous days were already high, right? So it should be 1. Now can you tell me how do you solve it? So the problem statement says you will be given next. So current day stock price. We need to return longest increasing span. So that next method will be called, if you closely see here, whatever next method you could see here, this method will be called each time. So initially first time it will return pass 7, so you will get 1. Then second time it will pass 2, again 2, 1. Third time it will pass 1, so 1. Fourth time when you pass 2, you return 3. So that's how it should be. How do you solve it? Problem statement is clear, no?
Yes.
Because you only corrected this 9, right? So definitely it is clear. How do you want to solve it?
So, so each time we push the element into stack and then
Mm.
we calculate the current day price.
Mm.
Uh, the stack has the element which is greater than or equal to the previous element. Then we update the price to
Mm.
Uh,
Now, as per your logic, so first you will insert 7. Okay.
yes,
So okay, so see, you will insert 7. So definitely it will has stack is empty. So that definitely you will return 1. Then you
correct.
will insert 2, right?
Yes,
Then
has to be less than 7.
mm.
I mean, we'll check again next element.
Now what
It
you
is
will
1.
return here?
It will be 1
It will be 1. How do you return? How do you know that it is 1?
because this element is less than 7. This
Mm.
is the highest price that
Okay.
is having
Then
value.
when you go into 1, again it is less than, you will return 1. Fine.
1.
When you go to 2,
Yeah, when we go to 2,
mm.
what we do is we check with the previous elements. We'll
Okay.
loop
It
through the
means
stack.
you will just remove this one and this one. 1 plus 1
Yeah,
plus 1. So then you will
yeah,
return 3.
correct,
Now when you
exactly.
go to 9, then
Yes.
when
So
you go
we
to
add
9,
the ninth element and 3 plus 1. Yeah, it will be
no, no,
5.
no. How do you know that? So now you are at 9, right? Then you delete
Yeah.
only these two elements, right? As per your logic, it will return only 2 plus 1. It was 3, but
Before deleting, we are adding the count to it, right?
where do you add?
I mean, 9 itself is 1. As we are removing 2, it will be 3. And for 7, it will be 1.
No, no, this is output, right? This is not the stack one. This is the output we track, no?
But the previous element, mm, longer span, we already know, right? So if a current element is greater than the previous one,
Mm.
you can just add it up.
Mm. That's good, man.
Yeah, that's what.
So um, that's a good. So that's a concept of dynamic programming. Okay, so that's a concept of dynamic programming. Your thought is good, so you can apply that. Uh,
Okay.
yeah, so I will also tell the same thing, but yeah, whatever algorithm you spoken, so just implement that. I will also tell one more use case. What I will do, so one thing for sure, when I am at 9, right, in the stack I'll have only 2 and 7, right? So I removed this 1 and 2, right? I removed
Yes.
this 1 and 2. In the stack I have only 2 and 7. So what is our job? I have to, one thing for sure, what is the previous, for 2 what is the count, so which is 3. For 7 what is the count, which is 1, right? Yes or
Yes.
no? For 7. So I need to maintain that, so that for 9 I can able to find out the count of this one and this one. Then whatever I'll get 4 here, so 4 plus current 9, so which is 1, so which is going to be 5. So when it comes to 2, it means for 9 I have a count as 5. Now when it comes to 12, so obviously these will be deleted because 9 is greater than this, these will be deleted. So in the stack only you have 9 with count 5. For 12 and you are having 9, so this will be deleted. I consider this count which is 5 plus 1, so which is going to be 6. So it means in the stack I have 12 with 6. Now when it comes to 5 and which is smaller, so that for 5 I'll have count as 1. Now how do you maintain this count in the stack, or how do you want to track that count? This
We can
count
have
is
a node
mm,
with the count as value and first value as
so
value
there are
and
two
next
things to
value is
consider, right?
value.
One is to compare the actual value, and if
Yes.
it is valid condition, we need to consider the count. So definitely you have two values in the stack. So one is so I'll take a stack of nodes. So one is having value, another is having counter, right? So
Yes.
another is having counter. So this will hold the value, this will hold the count of that value. So then you can consider it. Perfect. So finally, you will just return that counter. Now, what is the time complexity here?
It will be linear only, and at worst case will I mean twice will visit it.
Yeah, we visit twice, so it is going to be linear. And what is the space complexity?
Result we are
This is for
returning
overall, right? This is for overall, right? Correct?
yes.
This is for overall operation. But with respect to next method, what is the time complexity? So it is a next method, no? Next method you see, right? With
Yes.
respect to next method, what is the time complexity?
We are just checking the price. It would be constant.
Obviously, you are considering the count only. Price means you will calculate the count, right? But even
Yes.
in worst case, on and average, it's not n, right? Definitely, you keep on deleting the elements from the stack. So on and
Yes.
average, which is going to be constant, the next method, right?
Correct.
Correct, Maithili?
Uh, Actually, this next thing is kind of confusing for me. I'll look into it.
Yeah, so what the problem statement says, he is not giving array, right? He is not giving array. He wanted to design an algorithm. So what he's saying, he is keep on giving the first time he will pass 7. We need to return spam count as 1. Next time he will pass 2. We need to return spam count as 1. And again 1, 1. When he pass fourth next call, when he call next method for fourth time, he will pass 2. That time we need to return the spam count as 3. So what I'm trying to say, as long as no we as of now what we did, so we taken an array and we solved it, right? But in this case he's not giving an array, and each time he is passing the value. So we need to consider the previous values and find out the maximum stock streak count. So that's how we somehow we will maintain a stack and we will replicate it. So when it comes to next method, the time complexity is going to be constant, because either you have lesser elements, or maybe the top element can be higher to the compared to the current element, so that on an average you don't iterate the each and every element each time, so that definitely it is going to be constant. Is that clear, Maithili, or
Yeah, yeah, clear, Shreya.
okay? Let me implement this, so that what are we trying to do? So you are going to have a stack, and this stack is going to maintain the node. It will have so let me define the node also here. So this will have value, and this will also have counter. Or do you want to implement it, or can I write it? You will implement, how many?
Yeah. Anyway, we have to practice problems.
You didn't even type single code today. Okay. No stack. Okay, so what is the problem now? Now let's see. Now I want to find out current spam count, right? So I'll just take counter, which is 0. Okay, so this is current counter, you can say. Uh, so what you can do, so as long as your stack is not empty, and whatever value you have, right, stack dot peak, it will return the node. So whatever value you have in the stack dot peak, if it is less than or equal to
And current price.
current price, rather than value, let's take it as price. Okay, let's consider value or price, whatever which you feel comfortable. First change it straight. Okay, so I have updated. So whatever price you have on stack, if it is less than or equal to current, so this is more important. So you will add the counter, right? So you will pop it from the stack. Okay, so you will pop it, whatever counter it is holding, so just take that counter and add to the current counter. And finally what you do, so to the stack you push the current value, so with the node, so which is current price, whatever counter you got, so which is current counter plus 1, right? So because you need to consider the current element as well, finally return current counter plus 1. Is that clear? Kalyan, or is there any confusion?
No, I'll have a look into it. Yeah.
So span, so this implementation is okay. So what will happen later? Like the input, so we are building the stack.
So what is happening here? They call next method each time, right? So we just need to
Yeah.
return the count.
Oh, every time we are returning the counter, so
Yeah,
that's
that's what
what they are
that.
checking. Yeah.
Yeah, that's
Okay.
what they're checking.
Okay. So the input is not
Re-
provided upfront.
yeah. So
As
that.
it goes on, we have to calculate the
Yeah,
streak. Okay.
yeah, streak. That's it. So it's
Streak.
a design problem. So
Yeah.
kind of design problem. So we just need to design it.
Mm.
Yeah. So that's also, you see, he is keep on calling that next method, passing the value, and we need to return the count, spam count.
We
Okay.
are only adding to the counter when it's less than or equal. Yeah, got it.
Hmm. Don't look at the code when you are implementing it. Try by your own. Um, yeah, this is seems to be, this problem seems to be, yeah. Let me walk through it. So what he's trying to say is, he's given a longest path. We need to trim it and return the valid path. So what he's trying to say is, if the path is including dot, it is representing current directory. Double dot, which is representing parent directory, and how many slashes you have, which always representing single slash. And other than two dots, if you have any number of dots, which is going to be considered as a directory. So let me explain through the last input we had. Okay. Let me explain through this. How do I improve it? Okay, so that's fine. Okay, so this is the input we have. So let me copy that input. So the input is slash dot 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 slash a slash dot dot b slash c slash dot 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 slash d dot slash. So he is given a full path. We need to return the absolute path. So what he's trying to say is, if there are two dots, okay, so if there are two dots, and this is pointing to the parent directory. So these two dots means which is pointing to the parent directory. So definitely B is pointing to its parent directory. So whatever parent directory, immediate parent directory you have, so which is the, so we need to replace with the parent directory. So in this case you have three dots, and again you have B. Then after B, whatever you have, you will just copy that. So this is remaining same. Let me copy that, so and paste it here. Okay, so I just replaced B. So you see two dots, right? Two dots is representing B is belonging to the parent directory, whatever immediate parent directory. So you just need to trim that parent directory. Now again you see here there are two dots. So again you see here there are two dots. So it means D is belonging to the parent directory. It means here. So you just need to trim it out. So once you trim it out, so you will have three dots. Then B will remain same. This C will be replaced with D. Then again you have dot and slash. Now again if you closely see, you have single dot. Single dot means which is current directory. So that definitely you can ignore it. Once you ignore it, so this is going to be three dots, B slash D slash nothing you have. So what he's trying to say is, you always need to avoid the last slash. So that's what the problem statement says. If you closely see here, you have constraints here. So the path must not end with the slash. So here the generally you have slash here, right? So you have slash here after removing this current directory, but the path must not end with the slash, so that you can ignore this slash. And is also saying if it is a root directory, then you can include the slash. For example, the input is something like this. You have dot slash dot. So this is your input. So in this case, so you will have only one directory slash, so this is going to be the root. So if it is a root directory, you can include the slash in the output. So other than that, right, so it means two dots means it is a parent directory, single dot means which is current directory, any number of slashes can be considered as single slash. We need to trim the path, return the exact valid result. So for this given input, so any dots you have, right, for example, other than two dots, if you have three dots or four dots, which is considered as a directory, just like how you consider slash d, so this is also to be considered as a directory. So in this case you have three dots, so that which is considered as a directory, and you have two dots and b, so this b belongs to the parent directory, so definitely you need to trim this up, so this is replaced with b. Again you have two dots and d, so that this d is belonging to this directory, then this is current directory, that's why you got three dots slash b slash d. So we need to return this output. Is the problem statement is clear,
Yes.
Maithili? But this seems to be very complicated problem, right?
Exactly.
But if I tell you the algorithm, I think this is the easiest problem in the stack. Forget about, for example, in the second input, right? So second input, if you see slash home slash slash foo, right? So definitely we will avoid double slashes, and if you take the second input, it is slash home slash slash foo slash, right? So definitely this will be considered as a single input, slash home slash foo. As it is a complete path, you can ignore the last slash. Okay, this seems to be, yeah, if you look at the problem, right, definitely it is very complex. If you look at this input, definitely it feels like very complex, but let me tell you how do you tackle this. Three dots and a, and you have two dots slash b slash c slash two dots slash d slash dot slash, right? So I would say it is a simple stack problem. Can you tell me how do you apply stack? You don't have to say it is a stack problem because we are already discussing on stack. Maitri, any idea?
So we should ignore, so whenever we
Let's say you
encounter
have,
double dots,
yeah,
then we will ignore the previous one maybe.
yeah, but how do you write a clean code? That's correct. So when you have a double here, this is belonging to parent directory, so that you just replace with the parent directory. So I'll tell you, first of all, it is here the concept is very clear, right? So when you see double dot, it means when you see double dot, it means whatever current directory you have, it should be replaced with previous directory, right? Previous directory, right? So previous directory, and when there is a dot, so it should be a current directory, so you just ignore it. Then what else you could see, when you have three slashes, consider it as single slash, and what other than that, whatever you have, so either you have four dots or ab, whatever it is, all these are to be considered as directories, right? Correct now? Correct. Now how do you tackle this, right? So very simple. Let's say I'm for your notability sake, I am including two slashes here. Let's see what I will do. First I will split, because if I am know all these things, right, if I know all these things, for sure if I found it two dots, then definitely I can replace with the previous directory. So it means the previous one I can know through stack only. So what I will do, first I will split this complete input based on the slash. If I split this complete output based on the slash, this is how it looks like. So this is going to be 1, 3 dots, then this is going to be one more, and this is going to be one more, two dots, and this is one, this is one. So similarly separate, you have B and you have C, and again you have two dots, and again you have one slash, so it means empty, and one more slash you have, so it means for this you have, for this slash you have empty because there is nothing, and again you will have D, then again you will have dot, right? If I split it, this is the array I would get, right? Yes or no?
Yes.
Now you split it. Now let's see that magic here. So you have three dots. So it means it is a directory, so that I should consider it. So I'll keep these three dots into the stack. Fine. Now this is my stack. So I have three dots. Now I am having A. So A is nothing but it is a directory, right? Either it is three dots or any character, it is a directory, so that I'll include in stack. Now let's move on. I have two dots. Okay, I have two dots. Then what should I do? Tell me please.
Delete it.
Yes, delete the previous directory. We don't need previous directory, right? Yes or no?
Yes.
So I have two dots, so delete the previous directory. It means I deleted it already. So in the stack I have only three dots. Now again what I have? B, right? Correct now, buddy? So I have
Yes.
B. So let's
Yeah.
keep B. Now again what I have? C. Then again I got two dots. Then what should I do?
Delete C.
Delete C. Then I have empty space. Then I should ignore, right? If it is
Yeah.
empty, I can
Yes.
ignore. Then when I got D, then I will keep D into the stack.
Insert, yeah.
Now when I got dot, what should I do?
Current.
Ignore, right? Yes or no?
Yeah.
D
Yeah.
means
So
dot.
dot we should ignore. Yeah.
Ignore. Now in the stack, what I have? D, B, and three dots, right? Correct?
Yeah.
So if I iterate the stack, so what I get? Slash three dots. Somehow I'll iterate this one and B slash D. This is what the expected answer, right?
Yes.
Correct? Clear, na?
Yeah.
So
After it, we'll add the slashes back.
the only tricky part is this input and the problem statement makes us lots of adds us the complexity. But if you trim, if you split based on the slash, and so what you do when you iterate this stack, you will add slash and return it. So what is the time complexity here?
N, right? Big of N.
Yeah, so first we split, that is n, and stack also will take n, and space complexity also remains n, because in worst case you have all valid string, then it is equivalent to given length. So let me write this code. That's why don't, so what I'm trying to say is sometimes the problem statement and the input makes us very complex, but yeah, if you tackle this, things will be very smooth. So what I'll do first, I will divide into, I will split, so that path dot split of slash. So once I split it, then done, our job is done. So this is my stack, which will have strings, new stack. What is our job? So for each time you will get a token or path from this. Shall I make it as path or directories? Yeah, so it always good, it's a good practice to come up with meaningful name so that algorithm will be readable. So when do I delete? So first, so if my current directory, if it is dot equals to, if it is dot or current directory is empty, then definitely you will continue. Correct? Correct, nobody? Correct, na?
Yes.
Continue. So then what I'll do, if current directory dot equals of two dots, then what should I do? What should I do?
Delete previous, remove the pop the previous element from
Yeah,
the stack.
so make sure that you will check this condition. So if stack is not empty, then pop it. So better you will add it on the top. If it is equal and stack is not empty, and you just pop it. Then what else you can do? Else you can else if you can add if current directory equals what else? What else you could see? Dot you covered, two
Triple
dots you
slash or
covered.
double slash.
Uh, that's it, right? So I think you can simply else you can add a stack dot push of current directory, correct? Other than
No,
dot,
double slash and triple slash we haven't encountered.
we split it into slashes, right?
Oh,
Then
sorry,
you will have
sorry.
empty.
Yeah, perfect.
I think this is done right.
Yeah,
Yeah.
correct.
So otherwise you will push it. Then finally you are going to construct a string, right? So let's do that. What I will do, I'll have a string builder, new string builder. You know the stack will always return in the form of reverse direction, right? But we need a forward direction, no? Yes or no?
Correct.
So we need a forward direction, but it always returns in reverse direction. So what
And
you
yes,
can do, you can use enhanced for loop string. You will have directory, right, from the stack. So when you use enhanced for loop, it's just like iterator, right? It will give the forward direction. Got it?
yes.
Sp dot append of slash, because you append the slash, then sp dot append of current directory. And finally you can return by default if the stack is empty now. So there is a edge case, right? So if you consider this case, it is empty, right? In the
Yes.
example 4, so stack becomes empty. So if the stack is empty, then we just need to return root slash. Otherwise whatever thing you get, just return in the form of string. So that's it. So let me run. Double quotes missed.
You have to do.
Yeah, so what is happening here? So which is adding dot slash slash, right? Why? Okay, so why it is adding dot dot, right? If you closely see, it was added dot dot. The only thing is this is the condition we applied end on top, right? So that's why it was did that. It went into else block. If stack is not empty, then delete it. Yeah, that's it. This seems to be very hard problem, but if you split it, right, so then you will get a thought. Otherwise it is very tough to tackle that. Correct, na?
Yes.
Okay, let's stop recording.